rational numbers using an area model. And so we know how to do this when we're just kind of just applying this mathematically, numerator times numerator, denominator times denominator. But in this case, what we're trying to do is we're trying to get to this spot where what we have is a visual way of understanding like what's actually happening. And so what we want to start off is if we peel back the fractions. So let's say we take the 1/3 and we peel that back. And so we take the 1/3, now that 1/3, we're just going to take the 3 out of it. And we take the 1/4 and same thing, and we're just going to take the 4 out of that. So if we multiply those two together, we know that our total area that we would have would be 12 between the two. And that's the same thing. If we multiply, we're going to have 12 as our denominator here. And so it kind of helps us to understand the foundation. So these pictures are actually backwards. This fraction right here would actually represent the 1/3. And this one right here would actually represent the 1/4, because this orange area covers 1 out of 3 of the 12. And this one right here covers 1 out of the 4 of the 12. So one way of like kind of understanding how this really works is that it's an overlay. So what you're saying is okay, so I'm going to lay the 1/4 area model on with the 1/3 on top of it. And when I lay those on top of each other, I get this overlap right here. And there's only one spot, one of those squares that's represented in the overlap. And so that's 1 out of a total of 12. And so that, just like if we were multiplying with actual using the algorithm of the numerator times the numerator equals the numerator and so forth, we would find out that's 1/12. All right. So with that said, let's go down. And so this is just explained here at the top. I'm sorry about that. So that's just an explanation of the process. So let's do this. It's kind of like how we did this before. Take a minute and just, I understand that you're looking at letter A and you're like, whoa, 55 squares. All right. So just kind of like think about the process. Think about what's going to happen there. Maybe instead of drawing out 55 squares, but just think about how this is going to look and like how much overlap you're going to have. And so give you a second when you're ready. Come on, hit play. So hit pause now, go back and work it, and then come back and check your work. All right, welcome back. So I'm going to take a quick second and I'm just going to kind of sketch out like my abbreviated version of what we have there. All right, so this is my terrible attempt at this. There's supposed to be 11 equal distribution. So this is 1/11 right here. So like 1 bar out of a total of 11 is shaded. And on this one, it would be 1 out of 5. So now if I take that and I overlap that, so here's my shaded red one. And then I've got, that's 1, 2, 3, 1, 2, 3, 4. Yep, 1, 2, 3. And I want it a little bit bigger, so we'll just make it like that. Okay. So there's 1, 2, 3, 4, 5 equal sections. So in this case right here, I only have one little slice out of all of that. And so I'd have a total of 55 individual little cells that would be drawn if this is drawn correctly. And only one of them would meet my expectation. All right, do the same thing, hit pause, try to do letter B. And just so we're just trying to practice how to draw the model of the situation. Okay, so we're back. So we got 1/3. So we start off and, however you want to draw that. So I'm just going to try to go like that. And then I would say 1, 2, 3. And so this would be 1/3, right? And so the one thing I didn't do here with this is I didn't draw the other 7 lines, right? So I didn't break it down into 21 equal parts. So let's go ahead and see if we can do that. That'd be 6 lines. So that'd be 1, 2, 3, 4, 5, 6. All right. So out of that, I have 21 equal spots. Out of the 21, one of them out of the 3, that's the red part. And then I've superimposed the 7 on top of that. So now I shade in one of the 7s. So remember, so 1/7 is represented in blue and 1/3 is represented in red. There's a total of 21 total spots because we got 3 by 7, that's 21. Out of that, we only have one of them that's shaded for both, so 1 out of 21. So that's kind of looking at our area model with that. All right. Let's go down and take a look at real quickly. So clear that. We're going to take a look at division real fast. So very similar. So the question is how many 1/8? So when we have a division problem, let's kind of break it down for a second. Let's say 10 divided by 2. So basically we're saying how many groups of 2 do we have inside of 10, right? So we lay out 10. So we'll just do like this. And that means there's 9 spots. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, that was pretty good. And I'm going to divide that into groups of 2. So there's a group of 2. 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 And there's a group of 2. So we got 1, 2, 3, 4, 5. So same idea. We're saying here, how many 1/8 are there in 3/4? So we got to break that down. We got to kind of go to the similar situation to be able to do this. We need to go to the largest possible value. Just like here, the largest value we had, we don't have a denominator, but that's 10s. We had 10 drawn out, split into that. So in this case right here, very similar. I'm going to have a total of 32 possible quadrants or squares for my model. And so I can see that for the first model, total of 32, this guy would be 3/4. Because I've got 1, 2, 3 of the 4 shaded in out of 32. And on this one, I have 1 out of 1, 2, 3, 4, 5, 6, 7, 8. So a 1/8 representing out of the 32. So essentially what we're really doing is it's like saying like, oh, I've got 3/4. I'm going to make it into 32 on the bottom. That means I'd multiply by 8. That means I'd multiply by 8 and I get 24 32s. So if you count this up, that's going to be, let's see, 3, 1, 2, 3, 4, 5, 6, 7, 8. So 8, 16, 24 out of 32. So we're just scaling that 3/4 up or down to be able to get that visualization. So now to be able to actually divide this out, now to be able to do it, we're going to take a look and say, okay, so this represents 24. This represents 6. So if I take those numbers and I divide, how many 6s can go into the 24? I'm sorry, excuse me, I said that wrong. That's not a 6, that's a 4, excuse me. Then I say how many 4s, how many of these 4s can fit into that 24? And I find out 6 times. All right, so we got a couple more examples. If you want to hit pause, what I would do is, so you can practice, is I'd hit pause so you can't look at the image and go ahead and see if you can't draw it out. The whole idea is here is we're kind of trying to explore this. We're not trying to teach you how to like multiply or divide fractions. We're trying to teach you how to do it with an area model. All right, so hit pause. Try the example down here, the 2/4 and 1/5, or 2/4 divided by 1/5, and see if you can't come up with a solution. And then unpause and see what you got. All right, welcome back. Clear the screen. All right, so same thing here is that we look at those denominators. So we have a 4 and a 5. So we take that 4 times the 5 and we get 20. And remember, essentially what we're like trying to do here is we're saying, okay, I've got 2/4 and I've got 1/5, and I need to get those up to a common denominator of 20. Now, not because I'm going to add, because I'm trying to figure out, like, I'm trying to scale that up to figure out how many I'd have. So in this particular case right here, this would be times 5. So that would be 10. And this would be times 4. So that would be 4. And so when we take a look at the picture, what we see is that if I'm doing 2/4 out of my 20, that's half. There's 5, 10. And if I'm doing 1/5 out of 20, that's 4. So now I can take, in this case right here, that's 10 times my 4. And I find out that, I'm sorry, not times my 4, divided by my 4. And I find out that's 5/2 or 2.5. All right, got 2 more real quickly. If you want to hit pause, try those. And when you come back, I'll have it ready to go for you. All right, so for letter A, we start off and we know we're going to have 56. So I'm going to kind of cheat on this one like I've done in the past. So give me a second to draw and then I'll come right back. All right, so what I did here was I let the red be equal to the 3/8. So this is the red. And so in that case right there, I have 1, 2, 3, 4, 5, 6, 7, 8. So I've shaded 3 out of the 8. And then for the green, I used 1/7. So I took this, and this would represent my 1. And then I have 1, 2, 3, 4, 5, 6, 7. So I got a total, so that represents that. So now remember what we're trying to think about here is like, well, how many actual reds are shaded in? And so in this particular case, I have 1, 2, 3, 4, 5, 6, 7 times 3 is 21. So I have 21 shaded in the red. And on the 7, I have 1, 2, 3, 4, 5, 6, 7, 8. And so that's going to be 8. All right. And I'm going to hit pause real quickly to do that calculation. All right. So when I do that computation, I take 21, I divide it by 8 in my calculator. I come out with 21 eighths is equal to 2.625. So kind of hard to be able to understand or see that. Like when the previous ones are a little bit easier numbers, that's like actual something we can actually pull out. All right. So just using that area model, practicing that, how we do that, and when we multiply, how it's different than when we divide. All right, last one, we got 3/4. So I'm gonna hit pause. You guys do pause and then try it out and then come back and check your answer. All right, welcome back. So I've just drawn it out, kind of the same thing. I have the red superimposed on top of the green. So let's go back and color in the green. So I have 3/4. So in that case here, that's 1, 2, 3, 4, 5. So 5 times 3, that's 15 total shaded inside of there. And we do the red, which is 2/5. That's 4, 8. So that's 8 of them out of the 3.